All right, hey gang. I've got 6-1 to 6-3 review here, and I want to go over a couple of problems I think will be the more challenging problems on this review. Just kind of walk you through the thought process here, and then obviously finish out the rest of the problems for me. So, in taking a look at the first one that I've circled here, says here find the values of A, B, and C in the regular hexagon and justify your answer. Okay, now first of all, I want to make sure we review what this means. Regular hexagon. That means that all of these sides here are the exact same length. Okay, and that means that every single angle in here has the exact same measure. Okay, now I may have made that picture a little bit harder to see because there's so many angles in there, but all those angles have the same measure. So what I'm going to do is I'm going to figure out the sum of all those interior angles and then find out what one interior angle measurement's going to be. So if I go ahead and use this formula, n minus 2 times 180, that's the sum of all the angle measurements. And if I divide it by the number of angles or number of sides, it doesn't matter what you plug in there, it's the same either way, you're going to get one interior angle measurement of a regular polygon. So if I do that, there's 6 sides to the hexagon. So I'm plugging in 6. And if we take a look here, 6 minus 2 is 4 times 180. Okay, 720 degrees. That's the sum of all those angles. If I divide that by 6, I get 120 degrees. Okay. So let's see here. Where should I start? I'm going to put angle Q as 120. Okay. So if I was to redraw this triangle XQR, it looks kind of like this. XQR. This is A degrees. And we know that this is 120. Okay. Now I hope that you're fixing your eyes on the fact that this is an isosceles triangle. So the base angles have to be congruent. So I'm going to put that this is 8 degrees as well. So from there, if I go ahead and do something like this, 2a plus 120 equals 180, I can go ahead and solve for a. Okay, 2a plus 120 equals 180. So if I subtract 120, I get 60, and divide by 2, you get 30 degrees for A. Okay? Now, as I look over here, this angle right here is 30 degrees. Okay? If you remember the entire angle QRS, we mark that as being congruent to angle Q, angle V, and all the other angles. So if I go ahead and take, let's see here, 120 degrees, the measure of angle QRS, and subtract 30 from that, that'll give me B degrees. So this is going to be 90 degrees. Oops. 90 degrees is the measure of angle B. Okay? And it kind of looks like 90 there. Okay? Now, from there, let's see. How do we want to do this next part? Well, here's what I would do. And there's several ways to attack this next part. I may even go in here a little bit further so you can see that picture better. Okay? There you go. These two triangles are actually congruent to each other by side, angle, side. Side, angle, side. So that means that this is also 30 degrees right there. Okay? And then this angle will be 90 degrees. Okay? So as I'm looking at these two triangles, I'm going to say that they are congruent by hypotenuse leg. This is 90 degrees. This is 90 degrees over here. Remember we solved for B a moment ago, 90 degrees. So it's a right triangle. We have a hypotenuse and a leg congruent. So what that means is that this angle here and this angle here are congruent. Okay? Well, if you remember what the measure of this whole angle was, that was 120, right? We found that over here. Okay? And we divide that by 2. 120 divided by 2 is 60. and that's going to give you C degrees, okay? So again, A is 30, B is 90, and C is going to be 60, okay? Now, the next one, again, these next two are pretty detailed problems here. The figure to the right is the top half of the regular polygon. Find the measure of angle A. Now, what I think would be best is to figure out what this polygon actually looks like. So if I draw this out, I might do something here, here. This is going to be a very rough sketch. It would look something like this. Okay, so EFG, maybe we'll go H, I, J, K, L. Okay, so how many sides does this polygon have? Well, if I look at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like a decagon to me. Find the measure of angle A, this angle right here. Well, it looks like we're finding just one angle, and it is a regular polygon. So I'm going to use that formula right there. 10 minus 2 times 180, and we're going to divide that by 10 to get the measure of the one angle. So 10 minus 2 is 8 times 180. Oh, 8 times 180. Divide that by 10. That angle at A is going to be 144 degrees right there. Okay? 144 degrees. Okay? All right. Now, the last one, again, working with these understandings of regular polygons. Polygon, blah, 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 are both regular polygons. Okay? What's the measure of angle CBD? CBD. Ooh, interesting. Okay. So what I'm seeing is this. We know that each of these interior angles of the... Ooh, get that down there, sorry. Each of these angles of the regular pentagon have the same measure, as do each of the angles of the regular hexagon. Okay, so to find the angle CBD, this angle out here, I'm going to find the measure the angle of the regular hexagon, the six-sided polygon, and I'm going to subtract out the area of one interior angle of a regular pentagon. Okay, so for a hexagon, one interior angle, there's the sum, there's one interior angle. Okay, and I'm going to subtract that. Here's the sum for the pentagon. There's one interior angle. Okay, so if we do this, I think we already had this one. I think this was 120. 4 times 180 divided by 6, yep, is 120. 3 times 180 divided by 5 is 108. And so the difference is 12 degrees, and that's the measure of angle CBD. Okay? And so I hope that makes sense. Take the difference of the two. What's left over is that little baby angle out there. Okay? All right. Now, what else do we want to look at? There was at least one other problem I thought would be good to kind of go over with you guys. Give me a moment here. No. I think it's number 9. Okay. All right, number 9 says this. A park near Carla's home is a parallelogram, as shown in the figure. Side JK is 3 times as long as KL. This is key right here, okay? So if this segment is 3 times the length of this segment, I'm going to go ahead and say, what if I were to make this segment X? Okay? Well, we know that the opposite sides are congruent, and if this is 3 times as long, this side will have to be 3x. Okay? And, well, if the perimeter is 1,200 feet, I can add up all those x's. And go ahead and figure out what x will be. Perimeter is 1,200 feet. Okay? So right now we have 8x is equal to 1,200. If I go ahead and divide through by 8, 8 goes into 12 once. 150, I think. Okay. Oh, there it is. 150. Okay. I'm going to say feet. Okay, so each x is worth 150 feet. Now, if I want to find KL, well, that's just x, that length, as we said a moment ago, 150 feet. Okay? So, like I said, I hope that clears up any questions that you may have had. I can tell you there's some pretty difficult questions here that I still left out there that I think I want to see how you can do those. But, yeah, I think that's a good start. So, go ahead and finish up the rest of that worksheet for me, and then we'll talk about your answers the next time we're in class. Thanks for listening, guys. Bye.